Let's think about what happens now if we know the rate function to be 0.17t minus 12. We know that the rate function is the derivative of our depth function, so we can write y prime equals 2at plus b, and that corresponds to our y prime equals 0.17t minus 12. Our rate function is our y prime function, so this 0.17t minus 12 is our y prime. Now this tells us that b is negative 12, and 2a is 0.17. Now if 2a is 0.17, a is half of that, which is 0.085. This rate function corresponds to this depth function, in that whenever we have this depth function, we do have this rate function, as we've seen. So if we note that a for this rate function is 0.085, we see that we're going to put that 0.085 in for a here, and we're going to get 0.085 t squared. The negative 12 is our b, so we're going to have negative 12t for our bt, and then plus c. Notice that our rate function here doesn't tell us what c is. It turns out that c could be anything. It doesn't really make a lot of difference as long as c is some fixed number. The value of c, it turns out, corresponds to where we're measuring our depth from. We could measure the depth from the ceiling, we could measure it from the hole, we could measure it from any place as long as we agree on the place and keep it the same. And that's going to affect this number on the end here. But we're not going to worry about that now because we're going to see something really neat. We see that if we take this depth function and evaluate it at clock time 2 seconds, we get negative 23.66, that'd be 23.66 centimeters plus c. We understand these depths to be in centimeters. And if we evaluate the depth function at clock time 5 seconds, we get negative 57.88 centimeters. What does this tell us? Well, this tells us that our change in depth between clock time 2 and clock time 5 is negative 34.2. That should be familiar to you. That corresponds to the negative 34.2 centimeters we obtained when we multiplied the average rate of depth change here by the time interval. But we didn't have to go through this process. All we had to do was figure out what depth function goes with this rate function, and calculate the difference in the two depths. And we could calculate the difference in any two depths. As a matter of fact, we know now the depth at any instant, so that by starting with the rate function, we have determined the depth function, as long as we agree on a value of c.